So, yeah, hello everyone. Uh, for some time, for like uh, 3 to 2 months, okay, 2 to 3 months, I am practicing DSA for uh, for getting a job. Now I'm practicing from Take You Forward and Strivers A to Z Street. So currently I am in recursion. So yeah, I will. Okay, not this. Okay, okay, yeah. I was solving this problem, consecutive ones not allowed. So given a positive integer n, count all possible distinct binary strings of length n such that there are no consecutive ones. Okay. So now I have to tell the count of strings uh, where each string will have n number of characters, n number of binary integers, I mean 0 or 1. Okay. And there should not be two consecutive ones in each string. Okay. Now I have to tell that how many strings I can generate with no presence of consecutive ones. Okay. So yeah, constant is given that n is between 1 to 44 inclusive, and expected time complexity is big of n, and auxiliary space complexity is big of n. Okay. Okay, fine. So I have built a simple solution that, okay, let me comment this out. Okay, and also, sorry, so this one, and let me uncomment it. Okay, now I have already written a solution, okay, which was okay, but it's actually running in power in. Okay, so yeah, okay, let me run it. Yeah, it's giving correct answer. If okay, let me check for another custom input. Let me check for 10 and 20. Okay, so I have given the size of n, I mean the size of each string, okay, with no presence of consecutive ones. So here n is 5, n is 10, and n is 20. Okay, now if I compile this, okay, all three are giving correct answers, right? So this is okay. This is running okay. And now if I give another the problem, I want to show you the problem uh, this where this code will not work. If I give this 25, okay, I'm increasing the n. Okay, uh, it will be up to n will be up to maximum of 44. Okay, so I'm giving 25, right? Okay, now if I run this, okay, it's running. Okay, it's running. Okay, very good. Very good. Now if I give 30 and compile, okay, then also it's running. Okay, if I give 44, then run this program. Ah, look, look. I mean, I don't know. I was solving this problem before. For n is equal to 25, it was giving runtime error. Not runtime error. It was giving TLE. I mean, time limit exceeded issue. So it was not optimal in time. Okay, now I don't know. There may be some server issue. For 25 it was not giving result, but now it's running for 30. It's running, but now the worst case, I mean not worst case, the maximum in 40 for 44 is giving runtime. If I run again, we'll see. Okay, for 44 it's giving runtime error. If I erase this input and instead I give 30, okay, now it will run correctly. It will give the correct solution. Look, okay. So the solution is okay. Solution is okay, but as I am calling two recursive function, two recursive calls here and here, right? So I'm calling two recursive calls right now. For each call, it will have again two recursive call. Now for n number of time, okay, for n number of time, it will call 2 to the power n, because at each call it's giving uh, two another calls. So the time complexity will become 2 power n. So that's why the problem occurs for n is equal to 44. So now we have to optimize it. We have to optimize it. Yeah. Now how can I do it? I'm thinking for so long, but I was exhausted. That's why I came to make a video that if I am going to solve it or not. Okay. Okay. First of all, I was doing instead of doing two calls. Okay, I just want to implement backtracking. So now comment it. Okay, but this is the wrong solution here because I have written it wrong. Okay, let me check. Okay, I'm doing it in my notebook to check where is the solution going wrong. Okay, if I take n is equal to 3, then okay, then size of the each string is 3, and there should not be uh, two consecutive ones, right? So when is of when the length of s is equal to n, okay, then I am including the string as a valid string. Valid string means without any consecutive ones. Okay. Other else, then when the length of s is less than n, I mean I should do okay, fine. Else dot pop back and then wait. If I run it, yeah, it's giving correct answer. Yeah, yeah, fine, fine. Okay, there is the problem. Okay, look. Okay, if I okay, let me go to the worst case. Okay, it's giving runtime error. But why? Okay, let me check it for 40. Hmm. Oh, okay, okay. It's actually giving the correct answer for this solution. Yeah. Okay, let me uncomment this. Now it will not give the solution correctly. Yeah, look, all are giving output as 1. That's the problem. There is something logical issue. I'm getting some logical issue. Let me check. Okay, okay, I'm going for to write on it. 1. I pushed 1, then again I call it, then goes to 1. Then it's then it's okay. Also I'm pushing back to 0, and I'm again calling. Okay. It's not equal to 1. Then 1 0 1. Okay. 1 0 1. Then I'm again calling. Then I say n. Then I stop for. Okay. Sorry. This line will not work. Then I'm pushing 1 0 1. Then back to. I'm pushing back to 1 0 1. Then I'm popping back. And 1 0. Okay. I'm popping back. Then again goes to popping back. Okay. That's why. Okay. Do I need to again call it? Then again the same thing will happen. That I'm again and again making 2 calls for each point. Okay. Okay, let me do one thing. That first, what I'll do, that is dot push back 0. Okay, it will push all the 0, right? Push. Okay, then it will include the result. Okay, always there, always it will happen. Now, pop back if is dot empty and is of is dot length, sorry, -1 not is equal to 1, then is dot push back 1. Okay. Okay, let me do one thing. Instead of vector, then take set. Okay, I've tried. Mm, there's something I'm doing wrong, very wrong. That's why it's only giving the uh, single calls. Yeah, that's the problem. Okay, I found 2000 without copying it. Okay, because I don't need actually this thing. Okay, without copying it, I'm returning to the previous call. Okay, okay then. I should add a if to n, sorry, n and uh, okay. Let me leave it right there, because I'm not checking when the string length is n. Okay, I'm not checking there is any consecutive one or not. So I'm leaving it here. I will improvise it later. Before that, I'm doing it something store dot insert store.insert s, right. Then I'm copying it back. I'm removing the last element. Okay, now is dot length. I mean the last element. If the last element is 1, if the last element is 1, if the last element is 0, then what I can do? If the last element is 0, then I can, okay, that thing I think this thing I don't need 0. Then first of all I have to do is I start push back 1, right? No, not there. Then 001. Okay, I'm getting 001. Okay. Now I will copying it back, copying it back. Okay, done. So I took, no. This logic will not work. This logic will not work. Uh, I mm, I don't have I don't have actually any pen. I mean to write on laptop or something. Okay, that's why I can't show the guidance. Okay, but I'm doing it in a notebook. Okay, mm, please uh, please forgive me for that, because I don't have any graphical pen. Okay, graphics pen. Okay, um, okay. Let me do one thing. Let me do one thing that I will. Okay, right, complete. It's only having false of 5. How I can solve it with 5? How I can solve it? Only 5 calls. Only n calls. I have to think. Okay, I mean, let me try one more approach. Hmm, sorry. Yeah, it's again 2 power n solution. I don't know where is my actual problem is offering. I mean, set is okay so that there is no duplication of strings. I mean, okay, I think maybe. Let me check. Okay, some extra problem is uh, ex maybe this will offer uh, this have executes when mm, last character is not one. Okay, so this will not happen for every call. Okay, yeah, yeah. Okay, let me check if I can get any uh, predefined string function so that I can replace the length of the string. Both are same, but time complexity is constant, unspecified constant. Okay, but if I like, okay, this what is this back? Okay, okay. Returns the reference of last value in this string. Okay, I can apply it here. If is dot back, right? 40. That will reduce the time complexity a bit less, bit more. No. Okay, instead of pushing it back again and again, I can do one thing, that I will append it 0. Okay, first will 0. Okay, no need to pop back because it's actually a temporary value, right? And here also I don't need this. I will just add a 1. I don't need this line also. Yeah. Okay, okay. I will. Um, hmm. Okay, I can do one thing as dot append. No, this is the same of pushback operation. Uh, Okay, append operation is only happening between strings, right? It is, I'm giving it as a character. That's why this error occurs. No, why? Uh, okay, this will be one. Yep, should run. Should run the code. Cannot buy non-constant value. Reference by string. Okay, something I can do. String t equal to is 0 instead of t I will give t. That's the problem. No, no. Let me check this. Expected. Oh, okay, okay, okay. Maybe there is a other. Maybe I didn't put a semicolon right here under this. Control. Maybe okay. I mean, how can it be solved in big of n? Then I need iterative solution. It's can't be a recursive problem. I need. It can only be solved in big of n time complexity with iterative solution. With recursion, it can't be solved. Maybe I'm using the set. Maybe that's why the problem is happening. Well, I have reduced this. Maybe this is given as constant time in the website in the SCP reference. So this is a very good website, I must say. You can check size. Okay, the time complexity is unspecified in until C. Okay, since C++11 it's constant, so it's big of one. So there should be no problem in that. I have also used ACE.back, so there should not be a problem. And okay, maybe I don't need it here. I just do it like this. and I'll cut it. Okay, and also I will cut it. Okay, why this problem is happening? I mean, let me check it. Hmm. No, in my opinion, this can't be solved in with recursion. It can't be solved in big of n. I'll see the solution. I'll see the solution now. Okay, maybe this thing. Okay, I'll do this like t. Sorry, and I don't know why this is all that. Because actually, I'm not calling for all recursive call. I'm not calling two calls for all the calls. I don't know. Actually. Okay, now if I do this like effect and it will be okay, this will be vector, right? Let me check. Oh, so vector. Hmm. Okay, let me ask Yogi bot why this problem is happening. I mean, there is no syntactical fault I'm observing. It looks like you were trying to pass an empty string literal to the solve function which expects a non-const value returns to a string. In C++, string literal are treated as R values, which means they can't be bound to non-const values. To fix this, we need to create a string object first, then pass that object to the solve function, considering initializing a string variable with the empty string, and then passing the variable in state. This variable returns an value that can be modified using the function. Okay, okay, okay. I'll try that. And yes, okay. Let's try it. For 35, it's actually. mm, Okay, let me give this as 30. Let's try. The solution is correct, but okay, one thing. No, I need to see the solution. Okay, first I check the solution given in the TQ forward website. Yeah. What is the algorithm? At each step, try to place 0 or 1 at the current position. You can always place 0. Yeah, that's true. You can place 1 only if the previous letter was not 1. Okay, because until the length become n and select all valid strings, right? So, yeah, that's what I. Let, let me see. Okay, okay, they didn't take the reference of the string. That's why maybe they are able to concatenate the 0 or 1s in the calls, right? Okay. Whenever I'm taking the reference of something that's become const variable, right? In C++. So okay, let me do that. Uh, Control C, Control V, but why? Actually, I don't need. Why? It's actually the same solution they have given. Okay, let me check it in Python because it may happen that No, it's solution. It's the iterative solution. It will not work. It will not work. Mhm. They also didn't try it with recursion. Recursion it will need. Uh, they all have tried iterative solution. It is solved in recursion. It can be solved in recursion, but it will need DP. This solution is far more optimized than this. I can conclude that. Maybe this is the overfitting. I mean, in terms of machine learning, this is overfitting. But okay, so I think we need to do it in a iterative way. Okay, I will erase this thing. This thing are puzzling me a little bit. Okay, yeah. I just print the interface so that I can think it clearly. Okay, this solution will not work here because it is 2 power n solution. We need big of n because the expected complexity is big of n. Okay, let's try it with a different approach. Um, okay, okay, let's try. When n is equal to 1, then 0 and 1. Right. So uh, count is equal to 2. Right. There is no consecutive ones. Now when n is equal to 2, then 0 0 0 1 1 0 1. So count is equal to 2. Right. Count is equal to 3. Sorry, 3. Now when n is equal to 3, then 0 0 0 0 0 1 so 1 0 0 1 1 1 0 0 1 0 1 1 1 sorry 1 0 1 1 1. So here the count of valid strings is this one, this one, this one, this one, this one, and this one. Right. The total is 5. 5. Okay. Now when n is equal to 4, then 0, 0, 0, 0, then 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. Right. So this will be same when the first digit, right? So total is 16. Okay. Uh, for uh, total combination. Okay, I don't need it actually. 2 power 1 is 2. So when n is equal to 4, valid strings will be this one, 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 this one. Yeah. The total 1, 2, 3, 4, 5, 6, 7, 8. So total count is 8. Right. Okay. Okay. So now if we see, if we take this, I am seeing a pattern like when n is equal to 0, okay, then no strings is valid. So count, if I take count is equal to 1, okay, there is no valid string, so I'm taking 1, okay, okay, I don't need it actually. So I'm just building the pattern so that I can build the program. Okay, if I take this first, okay, first, if I take this as 1, A, then if I take this B, then A plus B is 5, 2 plus 3 is equal to 5. Then again, if I see that 3 plus 5 is 8, so I'm getting the valid count when n is equal to 4, right? So it's a Fibonacci sequence. Yes, it's a Fibonacci sequence. For 5, okay, let's see for 5. Okay, n is equal to 5. So all 16 combination will be there. See, 2 power 5 is 32. 2 power 4 16. So there will be 52 combinations. Okay, control V, and this. Okay, I'm putting a 0 at first because it's 5 digit. There will be 5 binary numbers in every digit. Yeah, let me do it. Okay, sorry. Let me take the multiple cursors so that I can put it 0 at once. 0. Okay, all digits are of 5 digits. Now I take this, Control C, Control V, backspace 1, going on, Control C, Control V, cut, delete, Control Z, Control V. Okay, now sorry, my mistake. Okay, copy this. Good. So now if I take the valid strings, so this one is valid, this one is valid, this is not valid, this one is valid, this one is valid, this is not valid, this is not valid, this one is valid, this one is valid, this one also, no, there is, okay, this one is not, this was not, this is not, this was not, okay, this was valid, this is valid, this is valid, this is not valid, this is valid, this is valid, and yeah, enough. So the count is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So count is 13. Right. So now if I see 5 plus 8 is equal to 13, so I'm getting it 13. So it's actually a Fibonacci sequence. So I can build it like this, that if n is equal to 1, then return 1 means 2, return 2, else if n is equal to 2, then return 3, else return count strings n minus 1, else in n minus 2. Okay, now I should m, also m bracket, okay, can do it like this. Okay, it is correct. Now if I take the 44 input, yeah, it's actually 2 per n. Okay, I can. Okay, I can do this in iterative way. That int a is equal to 2, comma b is equal to 3. I mean, a is equal to 2 for when n is equal to 1, and b is equal to 3 when n is equal to 2. Right? Comma c. Okay. Now for I equal to I less than n, I plus plus, then c is equal to a plus b mod m. Okay. So now a is equal to b and b is equal to c. Return c. So now I run. There may be a logical problem. Okay, this is running for 2. Let me check for 3. Okay, it's correct. Let me check for 4. Okay, it's correct. 7. Correct. 8. No, it's correct. For 20, it is correct. Maybe there has some problem. Okay, I can take it as LL. Okay, that will give me the correct. But I think maybe this is overflowing. Maybe this is overflowing. Yeah, now it is correct. Oh, why? Why this thing is going wrong? For 42 is giving correct answer. For 43, let me check. For 43 is giving correct answer. No, no. Why? Why there is a problem? Okay, if I don't mod it. Okay, I don't need to do mod. Let me check for 44. This modulus is giving some problem. Yeah. Okay. Hmm. So why I need modulus? I don't need it. Okay. Maybe I thought that maybe because the LL was there. That's a trick. Okay. The problem can be solved in two necessities. Yeah. This is the final solution. Now it has time complexity of big of n and space complexity is big of 1 constant. So yeah, good. Okay, I'm stopping this now. I don't know how much will you be helpful with this video, but I'm sharing my journey of programming. Okay, if you can connect with me, you can comment, like, share, and subscribe. And yeah, that's it. I'm stopping it for now.